everybody. I want to introduce you to another volume formula today. It's a special, but optional, volume formula for cubes, just for cubes. So go ahead and write this as your next title. When you've done that, close up your math notebook. Follow along with me till we get to the review. So let me remind you, before I get to a special one, we've used two different volume formulas for rectangular prisms so far. We used length times width times height was one that we often use. And we sometimes said, well, since really this, these two right here, length times width, we already know that from another formula. That's the area of the base that it's sitting on. That sometimes we used a second formula, which was volume equals big B times H, where the big B was the area of the base. So you can find the area of the base, then multiply by the height, or use length times width times height. You're doing the exact same thing in both of these cases. It's just a matter of understanding the two formulas and recognizing them. This one especially is going to be helpful. I want you to know when you get to like 7th grade geometry and you learn how to do things other than rectangular prisms, this one's going to be really helpful. This one won't. So that's why I really want you to know this one this year. So I want to introduce you to one more. So cubes are a special case. So when I look at this cube and I want to find the volume, something happens. So if I use my either formula, why don't I use the big B times H formula. So what I would do with this cube, I have to kind of imagine my back here. I like to have all the dimensions there wherever I can see them. Helps me visualize a little better. Am I missing? Something's missing here. I don't know. Maybe not. So when I look at this cube, so if I'm going to use the volume equals area of the base times height. So the base is, since this is a cube, the base is a square. And the area of the base is 3.5 times 3.5. So that's the big B part of the formula. Times, I'm also going to then multiply that by the height, and the height is also 3.5. And so what you end up with here is when you use a cube in particular, since the length, the width, and the height are all the same, you end up with the same number multiplied by itself 3 times, which if I wanted, I could rewrite as the volume is going to be 3.5 to the third power. 3.5 times 3.5 times 3.5 is 3.5 to the third power. And so I worked this out with the numbers. I know this would be just as easy to do in your calculator, but I want you to know this. When you have a cube, we tend to have a separate formula for cubes. And you can use the other one just fine. But cubes have their own special formula. Since the length, the width, and the height are all going to be the same length, no matter how you orient it or what you do with it, a lot of times you'll see the volume formula for a cube be side to the third power. And that's all you have to do. You just take this, take any measurement of the side, and raise it to the third power. And that's because when you do, you're really doing length times width times height. Because for this one, if I just use that formula, I'm doing 3.5 to the third power, which is 3.5 times 3.5 times 3.5. Which is exactly what I was going to do anyway. It all goes together. So this formula works out to being the same as this formula for a cube. It's just kind of a shortcut and like a slick formula that uses an exponent that you sometimes use instead. And so I would have 3.5 times 3.5 times 3.5. And my volume here would be 42 and almost 43, right? 42 and 875 thousandths of a cubic inch. All right. So that means I could almost fit 43 1-inch cubes in this box. Seems like a lot, doesn't it? Seems like too many. 3 times 3 is 9. Yeah, it does seem too high. Let me see if I did that right. Maybe I pushed something wrong. 3.5 times 3.5 times 3.5. Yeah, I guess I did. Just seems too high. My estimate was much too low. So there you go. All right, let's do one together. So I want you to know, here's the one we're going to use. We're going to use a cube where the side length is 4.5. So special volume formula for cubes. So the old formula, the area formula, or the volume formula for a prism is length times width times height, right? But for a cube, these are all the same. So what we usually say for a cube, we just say cube is length times length times length, or width times width times width. And we usually just write it as side to the third power, side cubed to the third power, like that. So if I want to use the formula to find the volume of this cube, I'm just going to say volume is side to the third power, which is 4.5 to the third power, which is 4.5 times 4.5 times 4.5 would be 91 and 125 thousandths of a square centimeter. There you go. This is actually an eighth as a fraction, if I made that a fraction. 91 and 1/8. Not square. Catch that. Cubic centimeters. I could fit a little more than 91 1 centimeter cubes in here. So that's it. That's the main thing. There's a special formula for volume. If you just want to remember length times width times height, or big base times height, that is fine. You'll get the exact same thing. But nice formula, and if you see it, I want you to recognize it. That's it. If you need any additional help, go back and watch these 2 examples again. If you feel like you got a good handle on them, you're all set. See you tomorrow.